So we're starting our new chapter on expressions, which is one of my favorites in the entire 7th grade unit of study. There's a lot of little tiny details. This is probably not new, but there's a lot of little details that I really want you to pay attention to because they do make a big difference. So the first thing I have is some vocabulary, some hints, some tips, and then we'll get into a couple examples for the first lesson. All right, so let's talk about a variable. You've heard this word so many times in math, but what is it? A variable is simply a letter, or it could be a symbol. And when we're in person, I usually get ridiculous and draw a sandcastle or a star or something like that. But it's something that stands for a number. Usually it's letters. Okay. Common ones you're going to see X, Y, Z, M, N, A, B, C, any letter that you want. Usually for what we do, we stick with lowercase letters. Capital letters can mean something different. So you could have a lower a and a capital A in the same problem, and they mean different things. I caution you with a couple of them, and some of this is just being disciplined and being neat with your handwriting. X is the most common variable, but we also use it for multiplication. So I want you to try to break that habit and not use X for multiplication anymore. You, of course, can use the dot, you can use parentheses, you can use the asterisk, or you can use no symbol at all, and we'll talk about that in just a minute. All right. If you're working with younger brothers and sisters and they're learning multiplication and they use the X, that's fine. Don't confuse them. But for what we're doing now, the more sophisticated middle school and into high school, try to avoid the X for multiplication. L can be a bad variable because it looks like a 1. So a lot of times we'll make it like a cursive L if you must use it. O is probably the only one I'm going to tell you to completely steer away from because there is really no way to fix it. You can try to do like a cursive O. It just never goes well. A Z, be really careful with your Z's. A lot of times you'll see me put a line in the middle. If you make your 2's without a loopy, sometimes they can look like Z's. So I make sure I put a loopy on my 2 and I put a line on my Z. It's just something I've learned over the years. I promise you that if you make that mistake, you'll figure out a way to fix it. S's can sometimes look like 5's, especially if you make your 5's all in one shot. Sometimes when you're writing fast, they turn out a little wonky. So just be careful of S's versus 5's. And then I, you just need to be careful that that dot on the top of the I is very clear. All right? All right, so we talked about a variable, a letter that takes the place of a number. Let's talk about algebraic expressions. Now, you've done these for a long time. There are two things in math. There are expressions and there are equations. So an expression is something that does not have the equal sign. The equation does have the equal sign. Okay, you can kind of tell by the root of the word there. Now, there are algebraic expressions and there are numeric expressions. Numeric is when there's only numbers. So like 3 plus 6 times 2, that is a numeric expression. It's all numbers, numeric, and it does not have an equal sign, expression. An algebraic expression just has letters. 3x plus 6 does not have an equal sign, so it's an expression, and does have a variable, so it's an algebraic expression. All right, coefficient. Think about the prefix co, like co-captains, or co-presidents, or a co-pilot. It means that you do things together. So this is a number in front of the variable. It's the number with, together with the variable. In this case, it would be the 3. In this case, it would be the -9/10. And in this case, my variable is v, and you're like, well, there's no number in front. Yes, there is. 1 happens so often, and mathematicians are as lazy and try to be as efficient as we can, we don't write it. Unless I absolutely need it, we don't write it. So that's what's called the understood 1. I promise that will trip you up once or twice before it sinks into your head. If you see a variable by itself and they ask for the coefficient, the number in front is a 1. You can write it. There's nothing wrong with writing it. But a lot of times we don't. Okay, so let's talk about some expressions and how you solve these. We'll talk about some examples in just a minute. When you've got two things next to each other, a letter and a letter, or a number and a letter, like I have here, that's multiplication. So this is really 4 times x, and this is really m times n. When we've got an exponent, that means the number or the variable times itself, however many times the exponent is. So if this was t to the fifth, it would be 5t's all being multiplied. Now, I show you that, and I know you've worked with exponents before, because when we get to an example like this, the exponent only goes with the thing it's right next to. So the 8 will not happen multiple times because there is no exponent with it. But the a will happen twice because the exponent is with that. We'll talk more about that, but I wanted to show you the difference. This is multiplication. Okay, handy. You cannot do that technique with just numbers. If you had, let's say, 3 times 6, I could not put just 3 times 6 because it looks like the number 36. So straight numbers still require a sign. Letters or letter and number combinations can have no sign. All right, one more vocab before we get into some examples. This is define a variable. We did talk about this just a little bit in 6th grade. Most students hate this step because they see it as unnecessary, but I promise if you start doing this, it will make them so much easier, okay? All you have to do is say let, and then whatever letter you pick, equal. Let X equal the number of dogs if the problem is talking about the number of dogs. Let Z equal the price of an apple. Sometimes you need to be specific. Maybe Z is going to be the price of an apple and W is going to be the price of a watermelon. That's where it's very helpful. And then, something like let W equal how far I walked yesterday. Please try to do those. I promise you, if you get in the habit, it will pay off, especially as we get into the more sophisticated problems later in the year. Okay? All right, I have 3 examples for you. Thanks for hanging in there with me. This is a lot at the beginning of a chapter. So let's say the problem is 8w minus 2v, and you are asked to evaluate the expression that's the words that they'll use, evaluate the expression when w equals 5 and v equals 3. Now, the beautiful thing about variables is that they can equal just about anything. They can vary. That's what the word means. Vary means to change. So it could be, for this situation, maybe w equals 5 and v equals 3. If we talk about the same setup a week from now, maybe w is going to equal 8 and v is going to equal 1 because the situation changed. But I didn't have to, what they say, reinvent the wheel. I didn't have to recreate the expression. I'm just going to change the numbers that I put in there. Now, my suggestion to you is that you only do one thing at a time. Don't try to do too much, and don't try to do these in your head. So the first step is to replace or substitute. Okay, everywhere there's a W, I'm going to replace it with a 5. So that's 8 times 5. And everywhere there's a V, I'm going to replace it with 3. So that's 2 times 3. Now you've turned it from an algebraic expression to a numerical expression. See, all these vocab words pop back up. Now you just have to calculate it. By Dear Aunt Sally, by order of operations, I'm going to do the multiplications first. So this becomes 40, and this becomes 6, and then 40 minus 6 is 34. So this is the solution, or the answer, and we have just evaluated it. You don't really solve because solve means something different in math that we'll talk about in the next chapter. All right, let's talk about another example. 2 parentheses, n plus 3. So when you're reading this to somebody, you might say 2 open parentheses, n plus 3, close parentheses, or 2 times the quantity of n plus 3. Quantity can signal parentheses in there. Now, parentheses have multiple jobs. In this case, it's holding together the n plus 3 and says do this first, but it's also working like a multiplication symbol. So this is 2 times everything that happens in here. All right, so we're going to say evaluate this when n equals -4. I know, we throw negatives in right away. You'll be okay. Take a moment, rewrite it where you replace the numbers, you substitute the new values in, then go back and calculate. Now, by Dear Aunt Sally, by order of operations, I need to do what's inside the parentheses first. So this is 2 times -1, right? Because they're different signs. So I have to subtract, keep the sign of the bigger number. Now this is going to work like a multiplication sign. So 2 times 1 is 2. There's a single negative. So my answer is -2. All right, I got one more for you. 4y cubed, exponent of 3 we read as cubed, plus 2. And y equals 3. Now, if this messes you up, if you're like, well, does that go in? Write it out. 4 times y times y times y, right? I got to keep 3 fingers up. There we go. There were 3 y's. So if I was to do it with the numbers, 4 times 3 times 3 times 3. All right? 4 times 3 cubed. You could write it out if it makes more sense, and then keep that. All right, so 3 times 3 is 9, times 3 is 27, times 4 is 108, and we add them together, and my final answer is 110. I have one more thing, one more hint to show you. If you see this, and sometimes it will be this, sometimes it will be more sophisticated. This is a fraction, yes, but the sign in the middle can also mean division. So it might make more sense to rewrite it with a different division sign. This can also mean, because remember our understood 1, this can also mean 1/2 times y. All right, you're going to see things like that, and I want you to be very flexible in how you interpret them. We're going to do tons and tons of practice. You're going to be amazing at these. Don't sweat it.